Hello, Mr. Malo here, your online math teacher. Welcome to my channel. Today we're going to be continuing my video series on hypothesis testing, and in particular we're going to be looking at part 2 of my one sample for z-test for population proportions videos. So if you found this video helpful, consider smashing the like button, subscribing, and let's go. So in this video we're going to look at a two-sided alternative hypothesis example, whereas we did a one-sided in the previous video. So here we are again going to use the four-step process. So state, plan, do, conclude. In state, remember, you need your hypothesis, you need the significance level, any parameters you're going to use, as well as your sample statistic. In the plan phase, you need to state what inference method are you using, as well as check your conditions. The do phase, if your conditions are met, that's where we perform our calculations, which they're going to be computing a test statistic as well as finding your p-value. And then finally, you'll conclude, so you'll interpret your results within the context of your problem. So let's jump into an example. So for our two-sided alternative hypothesis example, we have the following, and the order of these is wrong. According to the CDC, in 2019, 27.5% of all high school students reported current e-cigarette use. You are interested in this if this national trend holds at your large high school. To determine this, you take a simple random sample of 180 students from your school, and of those students, 40 responded that they currently use e-cigarettes. What should you conclude? Give appropriate evidence to support your answer. So you're just interested if this trend holds at your school. You're not making any guess about whether your school has a higher rate of use or lower rate of use. You just want to know if it holds. So are you different? So that's why this is going to be a two-sided alternative hypothesis. So let's jump into the stating phase. So we're going to perform a hypothesis test with a significance level of 0.05. So I didn't give you a significance level in the statement of the problem. So whenever you're not given one, you should default to assume it should be 0.05. Unless it's a life or death situation, then maybe set it lower. So in this, we are going to have our null hypothesis be that national percentage of 0.275, and our alternative to be the proportion is not equal to that, because you want to see if your high school differs from that national proportion. And again, P is the proportion of students at your large high school who currently use e-cigarettes. So, and then our statistic is 40 out of the 180 responded to current e-cigarette use. So now we want to go to the plan phase. Here, we're going to state the inference method. So we have a one sample z-test for population proportion P. And now we check the conditions. These conditions are the same as they were for confidence intervals, in that you need to ask, was your sample random? In this case, yes, it was a random sample of 180 students at your large high school. Randomness is what allows you to take your observation, your sample, generalize it to your population. So it's inference. Independence. Well, typically simple random sample, you're going 10% condition. If you have a large high school, 180 students is going to be less than 10% of students at your school, so it will be fine. And that's what's going to say taking a simple random sample is fine, so it still counts as independent, or essentially independent, and it allows us to also know what standard deviation formula we can use. Finally, we need to check normality. Well, if we assume the null hypothesis is true, which is what we do in all these hypothesis tests, then the expected number of students who would use e-cigarettes is going to be 49.5, and the expected number that do not use e-cigarettes is going to be 130.5. Since both those are greater than or equal to 10, the large counts condition is satisfied, and that means that we can assume that the sampling distribution of sample proportions is approximately normal. So we are good to go. Our conditions are satisfied here. So now we're going to go over to the do phase of this. So here we're going to compute a test statistic and as well as the p-value. So again, if we have a simple random sample of size m from a large population that contains an unknown proportion p of successes, to test our null hypothesis, we're going to compute the Z-statistic, so the Z-score here. So it's going to be your statistic minus the parameter divided by the standard deviation of your statistic. So this is what we're using here. And after that, we're going to find the p-value by calculating the probability of getting a z-statistic this large or larger in the direction specified for alternative hypothesis. In this case, since we're interested in do we differ, we are in this two-sided thing. So we're going to find our z-score here, and everything that's larger than that, either a positive or negative version, that's the area we're looking at. So let's find the numbers in this problem. So for our test statistic, we can plug into our formula to get a z-score of about negative 1.58. So in our picture, this is our non-standardized normal curve, but that's confusing, so we really go over to our standardized land, and this is the picture we're looking at. The area in the tail in this picture on the right is going to be the same as the areas in the tails on the left, so we're looking at the area outside of z-scores of negative 1.58 and positive 1.58. So you can go to table A if, say, you're using the AP Stats form, that's resource guide, and it's going to give you the area to the left of negative 1.58 in that table. And since I know by the symmetricness of this normal curve, I take twice that to get the area in between the two tails is 0.1142. So now you have your p-value. So now we can go to our conclude phase, where we always are going to compare that p-value to the significance level. So since our p-value of 0.1142 is greater than the significance level of 0.05, then that's going to tell us we are going to fail to reject the null hypothesis. That is, we don't have significant evidence to conclude that the percent of students at our large high school differs from the 2019 national percentages. Now, I do want to put out a little warning here, and I'm going to go back, that this is not the same as accepting your null hypothesis. We are just failing to reject it. We do not claim that our high school has the same percentage, just fail to reject. They are different. Statistics says you fail to reject. That's it. There are some subjects that misuse hypothesis tests, and in those subjects, they would then accept the null hypothesis, but we do not do that in statistics. You fail to reject. So if you're this screen I have here, if you're wondering what a written out solution by hand would look like, because you're probably not making a PowerPoint, it would look something along these lines. This is my solution here. So I hope you found this video helpful. If you did, smash the like button, subscribe, and have an awesome day.